Bismillahirrahmanirrahim. We will continue with the double layer theory, and now we will also add the different energy levels and how the ionic concentrations link with the compression of the double layer theory. Now, what type of forces are acting on the colloidal particles? So, particles are interacting based on their charges, but at the same time there are some forces which we can find out, and these forces are also going to help us in determining uh, how the colloids will join together to coagulate. So first of all is the electrostatic repulsion forces, and then we have van der Waals forces. So van der Waals forces are for the attractive forces. If you try to develop a relationship between the energy and the separating distance between the colloidal particles, we can determine how the uh, energy and how these forces which we are talking about, these two forces, how these forces are going to relate with each other while considering the energy level and while considering the separating distance between the colloidal particles. So in this first case, if you take the repulsive force energy on the y-axis and the distance between the colloidal particles on x-axis, you will find that just in this figure, please consider that we are moving from the right side to the left side. So we are actually bringing two colloidal particles of same charge closer to each other, because we are studying the repulsive forces. So we are bringing two similar charges, two colloidal particles with similar charges closer. So we will keep them we will bring them close, and we will find that a stage will come when there will be maximum repulsion energy, and at that time the distance will be minimum. And at the same time, if you consider another case, in this scenario you will check the attractive forces and van der Waals attraction forces and their relation with the distance between the colloidal particles, and you will observe that as we bring the two colloidal particles together, in this case the colloidal particles are positively charged, and you will observe that these particles are going to have the maximum energy at a level which is at a distance somewhere before becoming before having zero distance between them. So this is the time, and this is the distance at which we are going to determine the energy levels. So these figures actually illustrates the effect of separating distance between two particles on the net force that exists between the colloidal particles. So as two particles approach each other, the repulsive electrostatic forces increase to keep them apart, while there is an energy barrier which is crossed, and then we will get them brought together. In this case, we will now add the energy level of the we will be combining these two figures here, and now you can check the energy barrier. So this is the energy barrier and net interaction energy which is shown here. Initially the colloidal particles are being separated, and we will have this energy level at which the a bond will develop between the two colloidal particles even they are having the same charge. So that can be ionic, that can be um, covalent, but still it will be joined together by some bond between them. And the it is because they are crossing the energy barrier. Now when this energy barrier is crossed, they will uh, join together to make a mixed colloidal particle. So they will agglomerate, and then they will have an attractive force in them which will be bringing them together, and thus a agglomerate colloidal particle will be developed. So in this figure you can observe the behavior of the energy barrier at this point. So this is the case when we have low ionic strength, and the concentration of ions is less. And at the same time, if you increase the ionic strength, and if you increase the concentration of ions in the solution, we will get this kind of um demonstration. You can check the energy barrier has reduced very much. This is the case when we will be having the energy barrier mm, overcome with the very less effort, because the in this case the double layer has already been condensed. Now once the energy now the once the uh, now why that has been condensed? Because the concentration of ions have increased. Now because of that increased ionic concentrations, the electrons are the ions are much more closely bound with the uh, fixed layer, and thus the thickness of the diffused layer has reduced in this case. So this is the requirement for destabilizing the colloidal particles. So if we want to destabilize the colloidal particles, we must have high ionic concentration and higher ionic strength, because of which we will have a reduced diffused layer. So this is something about this. And again, if you consider these formations here, this is just the same explanations, and I think if you go through these it is just the same thing. So zeta potential, as we talked earlier, it is the potential difference between the um, shear plane and the diffused layer. And the more the distance the of this diffused layer, and the more stable that compound will be. So these are the compound particles you can observe here. And if you read these lines, this is the conclusion of our whole discussion. The zeta potential is an indicator of surface electrical potential. When it is zero, the particles have the greatest tendency to collide, and they are therefore easiest to be removed. So what actually we are doing, we are trying to reduce the zeta potential. We are reducing the zeta potential by reducing the thickness of the diffused layer. And how we are reducing the diffused layer, we are reducing the diffused layer by increasing the ionic concentrations. By increasing the ionic concentrations, more of the ions are closely bound with the shear layer, fixed layer. So this is something very briefly explained here, and I think this we have already covered. this is so first, the most importantly used method, most commonly used method is this reduction in the double layer, diffused layer. But at the same time, we have some other methods as well, which include so this is the mechanism one, in which ferric chloride dissociate to release highly charged ions. And so we talked earlier, there are basically four mechanisms. So double layer compression is first, then charge neutralization is the second option, and entrapment in a precipitate is the third option, and interparticulate bridging is the fourth option, by the help of which we can coagulate the colloidal particles. And how we can neutralize the ions? We can the charge on the colloidal particles can be neutralized by the addition of molecules of the opposite charge. So more the opposite charged particles in the solution, the more neutralization will take place. So this is the another option. And then we can have some precipitate formations, which normally we can conduct by addition of aluminium and ferrous salts. So these aluminium and ferrous salts, as mentioned here, these will be actually added to the solution, and then they will combine with the OH hydroxyl group, and this hydroxyl group, and then finally we will get hydroxide precipitates will be formed, by the help of which we will remove these particles. So then the long chains of charged particles and natural polymers can act as a source, as a bridging source, which can be help in the destabilization of the colloidal particles. So polymers can induce coagulation by bridging between the particles. So bridge between one colloid and another. So this is another option, by the help of which we can conduct this procedure of coagulants. Some of the coagulants which are used are shown here. You can just go through it. So please go through it, and this is just the summary. And the important thing is this double layer theory, and in this double layer theory we have fixed layer and diffused layer. Two layers are there, separated by a shear plane. So please focus on this thing, it is very important. And this will close our lecture.